Yo guys, today let's take a look at the chain rule, and if you're struggling with differentiation, how you can use the chain rule to differentiate these nice and simply. And then when you get super comfortable differentiating these without explicitly thinking about the chain rule, happens. Does that make sense? So yeah, once you get good at this, you won't have to do it in the way I'm showing you, but this is what you do at the beginning and what I show all of my students at A level right at the beginning. So, how do we differentiate all of these 5 functions using the chain rule? So, when we see 2 over root of whatever, think about the most basic function, okay? This basically says differentiate 2 divided by root x, all right? 2 divided by root x. And in year 12, how would you differentiate 2 divided by root x? You'd write power half and then bring it up, all right? So for the first thing, we're going to rewrite it as y is 2, then this whole thing is going to come up. So we get 2 minus 3x squared to the power of minus a half. Then what we do is we now explicitly write it in terms of a function that we are super aware of. And we can do that by letting what's inside here equal u. Okay? Because if we let that equal u, we'd be left with y is 2u to the power of minus a half. And this is super easy to differentiate. dy by du. We bring down the power. So minus a half times 2. So this is a basic power function. We bring down the power, not one off the power. 2 times minus a half is minus 1. So I'm just going to say minus u, not one off the power. Okay? But we didn't want dy by du. We wanted dy by dx. So I need to get a dy by dx by somehow eliminating du and introducing dx again. And we can do that by differentiating this. Differentiate u with respect to x. Here, when you differentiate that, the 2 goes. Bring down the 2 is minus 6x. Now, this is the chain rule. Yeah? How do we use these two to make dy by dx? Well, if I put them next to each other, you'll be able to see it. Here, the du's need to cancel. These are just fractions. We multiply them together. And there we go. So we're going to get minus 6x times this. Minus 6 times minus is positive, so we get 6x. Then we'll have u to the power of minus 3 over 2. And then we know u, we made that substitution, is 2 minus 3x squared to the power of minus 3 over 2. Okay? If you wanted to do this really short, I'm going to make a video on this anyway. You just differentiate what's on the inside. Yeah, that's like this bit. So you just differentiate that, write it first, then bring down the power, not one off the power. Okay? It's a power function. So that is the chain rule though. Yeah, so that's how we differentiate that using the chain rule, and that's what we should be doing at the beginning of our differentiation journeys. Yeah, to make our life simpler. But then over time, you won't need to do that. So for the second one, how are we going to do that? Y equals 2 sine cubed 2x. Cubed, powers. I'm thinking about the same way as this. I'm going to rewrite it slightly as 2 sine 2x cubed. Okay? Now, how do we differentiate that using the chain rule? Again, like the previous example, I'm going to let what's inside be u. So I'll have y is 2u cubed, which when I differentiate with respect to u, bring down the 3, 6u squared. Then we obviously have to do the same thing here, du by dx. How do you differentiate sine 2x? You could do chain rule again and let 2x be z or something. That's long, guys. I won't do 2 chain rules in one, but you differentiate the angle. 2x differentiates to 2. It's the same concept though. Sine differentiates to cos. Angle stays the same. Then we need to multiply them together like we did before. So dy by dx is 2 times 6, 12 cos 2x. Then we get u squared. So we get 12 cos 2x. U, which was sine 2x, we square that, would be sine squared 2x. Okay, so again, another way of doing this is you differentiate what's on the inside, just write that at the front, Then you bring down the power, knock 1 off the power. It will give you something like this. You get your answer super quickly. Part 3, e to the x squared. Yeah, students get very intimidated by this stuff because they're used to having e to the power of 2x, e to the power of 3x, like really basic stuff. But again, how can we use the chain rule to help us here? Can you guess what we need to let equal u? The power. Because when you let the power equal u, we just get the very basic e to the power of u function, which when we differentiate with respect to u is just e to the u. Then here du by dx, we bring down the power, knock 1 off the power, multiply them together to get dy by dx. We get 2x e to the power of u, and we know u is just x squared. Okay, so very easy to differentiate exponentials, guys. You differentiate the power, write it down, e differentiates to e, and the power always stays the same. Okay, now the next one, we can think about this separately as two separate terms. We have y equals ln, so for IV, y equals ln root x. And I'm going to do y equals root ln x separately. Now, as you get more experience, you're going to do this all together. Now here, this is the thing about the chain rule, guys, is students get so used to it, they let u equal root x. And they forget that ln is just a logarithm, and it follows the same rules as log base 2, log base 10, all of this stuff. If you rewrite this, as we should, as x to the power of a half, we can just bring down that half and differentiate like normal, because we know ln x differentiates to 1 over x. So dy by dx here is a half, lots of ln x goes to 1 over x, so we get 1 over 2x. Okay? This one, again, it's a power function. Let's let u be ln x. So here we're going to get y is ln x, well, sorry, just u. I'm still so used to not writing it like this, but at the beginning we should. With ln x being u, we just get u to the power of a half, dy by du, bring down the half, knock 1 off the power, be minus a half. Then here, du by dx is 1 over x. Okay, so differentiating this and differentiating this, then we multiply them together. So dy by dx is a half times 1 over x, which is 1 over 2x. Then u is ln x to the power minus half. And there we go, we can write our final answer of dy by dx being 1 over 2x plus 1 over 2x ln x to the minus 1 half. Can you clean that up even more? Yeah, you can. Is it necessary? No. You could bring that ln x into the denominator and write root ln x. It's not necessary, guys. You could factorize out 1 over 2x. But if they don't ask, don't do. If you're in the exam, you ain't got time for this. And most likely it would be part of like a larger question of like finding the normal or tangent. You'd have to sub in a value of x, so it's not a big deal. Finally, part 5. Y equals 5 to the power of root x. I'm just going to write as x to the power of a half. So again, let's let u be x to the power of a half. Y would be 5 to the power of u. Differentiating u with respect to x. Bring down the half. Knock 1 off the power. Here dy by du. Now here you need to know that all exponentials differentiate to themselves. So 5 to the power of u. But then you need to multiply it by ln of the base. So times ln of the base. E does the same thing. E differentiates to e to the power of u times ln e, but ln e is 1. So that's why e to the power of u differentiates to e to the power of u. All right, now we just multiply these together. So we're going to get dy by dx is a half. We could write that as 1 over 2 root x if you want, because x to the minus, that will come to the bottom, and power half means root, isn't it? So that multiplied by 5 to the power of u, where u is root x, and then we get times ln 5. Is there a nice way of writing this? Not really. I mean, you could write this on the numerator, 5 to the power of root x ln 5 all over 2 root x. But granted, guys, when it comes to chain rule, it is very simple when you do this process of the substitution. But over time, you probably won't need to use it. But I recommend at the beginning for sure you use this technique before you're fully comfortable. Say, okay, I need to differentiate this, write that down. Then this differentiates to this, ln 5, but you must keep that function the same, which we will practice in the next video. And if you don't want to miss that, make sure you're subscribed, like the video for more. Well, if you learned anything today, I'd really appreciate it. You can head to the Lungang Reddit page if you want to submit your own questions. And if you're interested in my A-level maths courses, link is in the description. Nice.